Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to electric vehicles charging system. In this particular video, we will be having look into what are the different type of charging source for an electric vehicle available. With that, we will also explore how these charging mechanisms works with the help of the different charging systems available in electric vehicle. So as you can see on the screen, there are totally two ways through which you can do the charging of electric vehicle. One is through the DC charging power stations or DC charging stations. Another is AC power stations. When you connect the electric vehicle to the DC power station, so basically the power source that you will be using in this case is the DC current. For the same, you may not need a rectifier to convert from AC to DC because here you are already using a DC power source. So why do we need a rectifier? So basically, as we deal with batteries, right? So batteries are a DC power source. So for that, whatever the source, either it will be AC or DC, we need at the end DC power source to charge our battery. So while charging the battery, that is called the charging process. So in case of DC, you don't need an inverter to do the charging, but as you are using a DC source, so you can directly charge your battery, but with a controlled current. Now, the second source of charging is the AC power source. You can see when we want to charge the battery, then at that moment we need DC, as we already discussed. So we are also giving an AC supply. So we need to convert it to a DC with the help of a rectifier. So this process is done with the help of a onboard charger. So basically when you connect the AC power supply, then your electric vehicle will be able to know like this is a AC power supply and I need to turn on my or I need to pass the current through my onboard charger. So when it passes through the onboard charger, the power source is being converted from AC to DC and the electric vehicle battery got charged. So coming to the DC and AC charging infrastructure difference, so there are multiple levels of chargings based on the level of the voltages that are being used for the electric vehicles to charge. But coming to the major difference that you see in a DC and AC power station is DC power stations are having like high voltages, and if you want to do perform fast charging, then you can do it with the DC power stations only. So these power stations are being connected to the grid directly, and there is a rectifier present here, which is a big rectifier with a higher power rating, which basically converts this grid AC into the DC inside this power station, and through that you do charge your electric vehicle. So the rectification process in this particular case will be happening inside this box, but whenever you deal with the AC, then the rectification process happens inside the vehicle itself. So that is why this is called a onboard charging module and or onboard charger. So when you do connect the charging port, as you can see over here, if you are connecting the charging port, the charging automatically will not start at the same instant. So there will be some protocol that need to be followed to start the charging process that we will see later on in this particular video. If you want to analyze like what is there in the charging port and how this charging process happens, let's have a deep dive into the same. So if you see the charging port, usually the charging port will have around 7 pins, and some of the pins you will be knowing as we are using two power source. So you will be using either AC or DC. So there should be provision for both the power supply to enter inside the vehicle. So if you see the pins, this is the pin for DC negative and this is the pin for the DC positive. So if you see here in the pin out of these like 6 and 7, these pins, will be supporting for DC charging. Next, we have 3 more pins, which are these 3 pins. These 3 pins support the AC charging. The top one is the ground part or the protection of the equipment. This is the neutral port and this is the phase port. So as you already know, that like in AC, you will have 3 ports and one will be ground, one will be phase, and one will be neutral. So that is how the power supply happens in the AC. So these 5 pins that you see are also bigger in diameter because these carries the power supply, and that means it carries a good amount of current, and that is why it needs more. It needs to be more thick to offer less resistance to produce less heat inside the charging process. If you see the power supply, what are the power supplies that are available for DC, then it will be like 400 volt DC, and it will be either a 800 volt DC depending on the country that is being preferred. So usually in Japan, we do have 800 volt DC supply or DC charging stations. So now question comes like why the higher voltage is used. So when you do charge the electric vehicle, we basically are transferring energy, and energy is will be like multiplication of voltage into charge, or in case like of power, it is like P equal to V into I, P equal to V into I. So if we are increasing the voltage, then we are reducing the current to provide the same power. So because of this, if we increase the voltage, then in that case, you will be getting less current for the same power transfer. So because of this, usually higher voltage charging stations has more efficiency, but there is also limitations like why we cannot increase more higher voltage because of the insulations that are present. So between the wires, we need to increase the insulations, and while converting also the power from the AC to DC, we need to convert and we need to use higher insulations. That is a limitation when you go for a higher voltage. But as the more voltage you increase, the current will reduce for the same amount of power transfer. And in case of AC, you will have 2 types of power supply. This is being used in India, and it is like 230 volt and 50 hertz supply. And this is basically used in US 120 volt AC with 60 hertz power supply. So these are the power sources that are available for doing charges, for doing charging in case of electric vehicle. These are household charging stations which you can carry, like this one, as you can see here. So basically you will just have a wall mount charger, and with the help of that you will be charging the electric vehicle. But this will be a complete charging station, and you will be charging the electric vehicle with the help of this charging station. Now we left 2 pins. One is the control pilot and one is the proximity pilot. So we will discuss in detail on these and how these things works in a detailed way. But coming to the overview, like how these things works and what is the basic functionalities of these. So if you see the control pilot, so control pilot has 3 major functionality. It will check whether the vehicle is connected to the charger or not, and next is whether it is ready to get charged or not. Like once you connect the charger plug, then should we start the charging or should we not start the charging? So that is being decided with the help of this control pilot. And the next stage is the charging process. So once it is all confirmed, it will also give a signal that whether the charging is in progress or not. So there is one more sensor we also discussed, right? The proximity pilot. Proximity pilot detects whether the vehicle is present with the EVSE or not. So basically EVSE refers to the charging station that you usually have. And with the help of the proximity sensor, it detects like whether the vehicle is actually connected to the charging port or not. And it detects also the presence of the vehicle with the help of different electrical signals. So those things we will see in detail in the next video. Coming to the control pilot, one more functionality the control pilot has is the control of the current that is doing the charging for the electric vehicle. Suppose you connected the electric vehicle to the charger, then in that case, the current flow will not start immediately. There will be a communication that happens between the charger and the electric vehicle. So suppose this is the charger and this is the electric vehicle. And in this case, suppose my charger has the capability to carry a current of 6 amps and my vehicle has the capability to carry a current of 12 amps. But in this case, both of them will communicate and will decide which one the current is allowed while doing this charging process. And this is being determined by the lowest current that is offered by both of the device. So in this case, it will be 6 amps. Coming to the another case where like suppose your charger is offering like 12 amps of charging, but if your electric vehicle is able to take 6 amps, then in this case also there will be 6 amp of current flowing in the charging process. So basically the minimum of both of the charge current carrying capacity is being determined, and with the help of that it is basically taken the minimum one and then the charging process is started. Now suppose I want to change my current while I'm doing the charging process. So usually at the beginning of the rise of SOC, like if your SOC of the battery is rising with and now you crossed around 80%, then in this case maybe you want to reduce the current and you want to do a constant voltage based charging. Then in that case, what should happen in this case? So as you can see, we are able to see a pulse width modulated signal, basically a square signal, and you can see the duty cycle for this pulse width modulated signal. So this signal will be sent from the electric vehicle to the charging station, and the more the pulse width for the on time, then the more current will flow in the electric vehicle based on the agreed current. So this duty factor or this duty cycle is being multiplied with this current, and then the current flow starts. So suppose the electric vehicle wants to get a lesser amount of charge compared to what it was getting previously, then it just need to reduce the duty cycle of the signal which is coming from the control pilot, and through that it can control the current in the charging ports. So basically it helps in also communicating and controlling the current that is flowing through the electric vehicle while the charging process is going on. And this communication happens at around 1 kilohertz of frequency, so that both the device like the charger and the electric vehicle gets the communication on time and can control the charging process. Along with that, so coming to the proximity sensor, so here there is one more functionality that is present for the proximity sensor. This helps in detaching the electric vehicle from the charging station safely. So that mechanism also we will see like how it happens in the next tutorial. We will also do some simulation on the same in this particular chapter, and we will see like how these things works and how the different voltage levels are being determined and how the current is being controlled, how the pulse is being controlled. So all these things we will see when dealing with the charging process. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. Have a great day ahead. Thank you.